The next piece we have here, as part of the foreshadowing I did in member-wise assignment, is a copy constructor, and this starts on 832. The idea here is to go and think about the following thing. In not advanced C++, but in 276, and I know that that may have been a long time for some of you. In 276, could you simply say string 1 equals string 2? Did that work? No. And what's the reason for that? The reason for that is each string is its own object, and as such, it is a copy of an object has to be created every time it is that we need to move that about, right? And the idea there is that a string is immutable in memory. It does not change. So what we cannot do is simply assign one to the other, or even when we say string 1 equals string 2. That's because we could not, it is entirely possible string 1 could equals string 2, and that's only if the actual memory location for them is the same. So why can't we, if in 14.4, if I used member-wise assignment, why is it that I can't always assume that I can say object 1 equals object 2 and have that work? And the reason for that is what you have been toiling away with all semester here, and that is the idea of the pointer. So if, as part of an object's member variables or member functions, we are using pointers, remember that those simply go to a reference in memory someplace. It is not, in fact, the same thing as, cardinal type variables would be. So it is not the same thing as simply copying over a value for an integer, or a value for a character, or a value for a double. All we're going to do is copy over the reference for an array pointer. We're just going to copy over the reference for an array of objects even. So better than rely on member-wise assignment, it is in your best interest to consider the idea of a copy constructor. Now, what a copy constructor does is it actually goes through and enables you to create a new pointer for your new assignment. And the way that we do that is here. So let me scroll down to where you will see. So that was the rationale, and that was here on page 834, and that is what I just talked us through. Is you are referring to a pointer, and therefore that pointer is not when you copy that over, you're simply returning the address for what it is that you are pointing to. The copy constructor we can see right here on 834. Now, a copy constructor is exactly the same as a constructor would have been when we were using it before. The only difference, and the way it is that C++ knows, okay, hold on, are you calling to a new constructor for a new instance of a class, or are you calling on a copy constructor to copy an already existing instance of a class, is based on the parameters list. If you'll notice here on 834 in this code sample, you'll notice in the parameters list that we have an object. So when you pass an object, so an instance of a class, when you pass that as an argument to a constructor, C++ is going to look at the arguments list and go, this one is an object. So I know I need to call a copy constructor in order to do that. So then you'll notice what happens here is we get object.studentName. So that is the object that we're passing in is stored in student name. Object.testScores, stored rather here in num test scores. And we go through the business of actually going through and copying all of the scores from that particular array. And what that enables us to do is sidestep the issue of these scores in this array are based on pointers. So this gives to us a new array that we can use that we've copied the contents into without simply copying the pointer over, which is going to potentially be an issue. Because remember, when we have objects, we can construct an object and we can destruct an object. So if part of object number 2 is pointing to object number 1 and object number 1 is destroyed, now we have problems. So the copy constructor here is important in that way that it deals with the idea of references. It deals rather with the idea of pointers, which is fantastic.